Here we go, record. Okay, great. Thanks guys for doing such a good job keeping to time. So the purpose of this talk is mostly to introduce myself because I'm new to the Ronin community. So I've got a little agenda slide here. Objectives are to introduce myself and my research in a kind of overview form. I won't spend that much time on any particular thing. I want to recap the sort of current state of climate science overall, and then prompt some discussion on the role of science and scientists during the climate emergency as inevitably reflected through my own experience. And then maybe we'll have time for discussion, hopefully. So my career path is started quite traditionally. I did a schooling on the East Coast. I did 2 postdocs, one on the West Coast of the United States and one in just south of Paris, France. And those are both in national laboratories of those respective countries. And then I started a scientist position at Oak Ridge National Laboratory. I don't work there anymore, and I'll get to why later on. And now I work as a remote scientist at Lawrence Berkeley National Laboratory, and I also work as a research scholar at Ronin, through which I'm sending some of my funding. And that's been very cool. I'm really grateful that you guys all exist. So I started as a forest ecologist. I primarily looked at the allocation of carbon below ground, the timing and the magnitude, mostly doing combination of field and lab work in different ecosystems in the northeastern United States. This middle picture here is me measuring carbon dioxide and methane in the Sierra Nevadas, more fire-prone Mediterranean ecosystem, and a warming experiment in the Arctic, for which we are hoping to publish soon. During my postdocs, I switched a little bit more to modeling, which is what is allowing me to work remotely. So developing models of soil carbon cycling, both including the role that microorganisms play in decomposing plant matter, and also the role that rock-derived minerals play in sorbing to basically sticking to organic molecules and sort of holding them there for hopefully long periods of time. And in recent years, I really switched more into ways to constrain both process-based and statistical models using field data sets, which is really difficult because, like, if you can see in this plot, these are field data from a litter input experiment. You can just see that they're, 1, all over the place, and 2, there aren't that many of them. So it can be really difficult to constrain models using field data, but it's something that, we think is really important. Another sort of line of research that I'm interested in doing is using, in this case, it's laboratory incubations of how much small molecules of carbon can sorb to rock-derived minerals, and using that plus remotely sensed data sets, kind of really large data sets, to try and estimate, for example, in this case, how much carbon we can sorb to rock-derived minerals, and coming up with a global estimate for that. That was using a more statistical model rather than a process-based model. We've also been leaning more on statistical models, especially as new algorithms, like you just heard in the last talk about newer algorithms, that have come out to make other types of predictions that are difficult to make otherwise. And so here we made a sort of consensus model of over 8,000 simulations of agricultural yield that happened in different locations around the world from crop models, and used this sort of meta model to assign what the greatest contributor was to the change in yield with a warming scenario. This was the RCP 4.5, which is a kind of middle of the road climate warming scenario, and found that applying some kind of adaptation practice, like changing fertilizer regimes or changing your irrigation scheme, can reduce the yield loss by up to 13%, which of course really depends on where you are in the world. And we also found that adaptation was one of the more important factors for many places in the world for most of crops. And that's sort of what this figure is showing. Pink is adaptation ranking as the sort of greatest contributor to the change in yield. And you can see that there's just a lot of pink on this map, which means that adaptation can be really useful, at least as understood by these crop models. The work that I'm doing now mostly tries to incorporate human effects, because I spent a lot of my early career studying natural ecosystems, and I'm now much more interested in the ways that humans interact with the natural world. So I'm trying to finish a paper right now that looks at how carbon cycling changes across a bunch of instrumented plots that go from a forest interior, this is an urban forest in Maryland, to the edge of the forest, and then across the other side to a more, meadow kind of urban lawn. And then we're also starting up a project looking at how shifting cultivation affects below ground carbon and nutrient cycling. Shifting cultivation refers to this, it's a traditional, often indigenous land practice in parts of Mexico, northern India, Ethiopia. We often in the kind of northwest, global north, call it slash and burn and really give it a negative connotation. But I think we're starting to sort of revisit the extent to which, this practice, which has been in use by people for, many thousands of years, might actually have some benefits for the landscape. In my spare time, I also do a lot of advocacy and activism. I spent the early part of my career mostly doing science education, like creating curriculum for students, and then interacting with governments, the French government. Here's Macron. I was taking this picture. This is my lab mate giving a sort of briefing about her work in climate modeling and in the United States government, and sort of really working with policymakers within the Beltway. And I'd like to now veer a little bit into sort of why, I think this is important, but it wasn't really enough for me. And so I started to do other things. Okay, a little probably review for everyone. So we've had many, interactions between scientists and politicians where we very calmly explained to world leaders that the climate is changing and we need to stop using fossil fuels. And yet, emissions and temperatures continue to rise without, a peak in sight. And then this is just the y-axis is gone, sorry, parts per million carbon dioxide, and the relative, budget that would, or the relative concentration of CO2 that would result in 1.5 degrees Celsius of warming and 2 degrees Celsius of warming. And of course, you see us barreling towards 1.5 and 2 degrees Celsius of warming. We know that. Recent studies, a study came out last year showing that exceeding 1.5 degrees of warming could trigger, and we call them tipping points, but they're essentially positive feedbacks in the Earth system, such as the collapse of the Greenland ice sheet, the abrupt thawing of Arctic permafrost, and mass coral reef die-off. And at 1.5 degrees, these things become more likely than not, but they're still completely possible. Like we are certainly kind of already in the danger zone. We're already in that probability distribution function where these positive feedbacks are, possible and happening. This is from the recent IPCC sixth assessment report, which some of you may have seen already, just showing how, people who were born in the 1940s will, over the course of their lifetime, experience a very different climate system than children who are being born now. And those of us, I'm sort of in this middle range, born in the 80s, that we're really changing the way that we experience the climate. And so, all of that was very distressing to me throughout my career. I really like this quote from Bill McKibben, who's a reasonably well-known activist, who said that it took him a while to figure out that we'd won the argument long before the science was abundantly clear. We were just losing the fight because the fight wasn't about data and reason. The fight was about what fights are usually about: money and power. And I fully agree with that. So, it led me to sort of think about ways in which I could sort of tackle that fight as a scientist. I got some more ideas from the indigenous ecologist Robin Wall Kimmerer, who wrote Braiding Sweetgrass, which is a great book that some of you may have already read. And there she says that science is rigorous in separating the observer from the observed and the observed from the observer. And to me, what she's telling us is, I think, the ethos of the Ronan Institute, as far as I understand it, which is essentially that we do science better when we understand what our value system is, instead of pretending that we don't have one, and that there are more kind of holistic ways to do science, more compassionate ways to do science, and that, like, inaction is also a political choice. as much as choosing to do activism is. Yeah, this is more about, practices of science are not always neutral. They can reflect colonial, extractivist, and geopolitical goals of the day. I think the first talk also touched on that. And some examples of, scientific advancement periods that were very geopolitically motivated. Okay. Hopefully everyone's on board with that general concept. I wanted to touch specifically on the role of fossil fuel influence in research because it's a particular interest of mine. That oil companies give a lot of money to both scientific institutions like the American Geophysical Union, and also have on their boards and give lots of money to US universities, as well as having prominent academics on their boards in order to increase their social license to operate. And that wording is actually taken from House subpoena documents. So that's kind of in their own words. They want to maintain their social license to operate. But it really does affect the research that we do. So this was a really interesting study that came out late last year in Nature Climate Change that looked at the sentiment towards natural gas. Natural gas is the example in reports that were put out by academic energy centers. So theoretically, these are unbiased reports. And so they should have, this is using like lexical analysis. So what is the sentiment of the words that were used in the report?
3 minutes. Sorry.
Okay, I'll try and wrap up. And so, IPCC, of course, which for some reason they call a pro-environmental institution, but I just think of as the gold standard of group science, is unbiased. It has a kind of zero sentiment. But these energy centers, non-fossil funded energy centers, have a slight positive sentiment. And of course, fossil funded energy centers have a really positive sentiment. And so there really is, at least in this study, an effect of where the funding comes from on the outcome of the research, or at least on the tone of the research. And so, scientists really have a lot of power in the types of research that we choose to undertake and the types of activities that we do in our spare time to make a lot of change potentially. And that's one of the reasons why I escalated my advocacy and activism. So, in April of last year, I chained myself to the White House fence like James Hansen in 2011 when he was protesting the Keystone XL pipeline. This is with 5 women and 2 Indigenous folks, and we basically asked for the president to declare a climate emergency. Since then, I've been arrested in different environmental protests or wealth inequality protests 6 times total. And despite those many arrests, my record is totally clean. I've been sentenced at worst to community service. And I think that speaks to the incredible privilege that I have as a person who looks pretty white, who's pretty cisgendered, who, is a scientist and has a sort of professional privilege. And so, I think that we discount a lot of the privileges that we really have. And often don't realize how much power, especially those of us who work and live in global north countries, have to create political changes. And some policy changes have happened out of these protests, especially the Ban Private Jets campaign. Maybe we can chat in discussion. Anyway, okay, I unfurled a banner at a conference and I got kicked out and I got fired. And that's why I don't work at Oak Ridge National Laboratory anymore. I would love to talk more about that if people would like to. But just so everyone knows, sort of what brought me here was certainly my relationship with institutions that were not okay with advocacy and activism. And however, the American Geophysical Union, despite kicking us out, has allowed us to come back. They reinstated our abstracts after we met with their ethics board. The ethics board met, and they decided to let us come back and introduce kind of advocacy and activism programming into the program, which is very cool and exciting. And so if anyone is planning to go to AGU, please consider submitting an abstract to one of our 2 sessions, Grassroots Activism for Scientists, which is very broad in its scope, and will be a series of short flash talks. So hopefully many people can participate. And then Science, Activism, and the Law, which looks at the sort of employment and legal implications of engaging in activism and also knowing your rights so that people are sort of prepared and understand their risks. We have other events here. Here's a list of them. We have a town hall on AGU's stance of fossil fuels, which has been approved. We have a grief circle, which is basically a way for us to kind of talk about and access and process our grief around climate change. And then we have, offsite action trainings, cool invited speakers. So yeah, please participate if this is something that interests you and you have the capacity to participate. And yeah, I guess I'll stop there. I just want to acknowledge I'm on the board of the Climate Emergency Fund, which makes donations, which gathers donations and make grants to activists. So that's like one thing that I'm passionate about. And I also do activism with Scientist Rebellion. And I should say that though I work at this other national lab, I do not speak on their behalf. This is all speaking on my own behalf for the sort of activism and advocacy part. And I'll take questions if there's time.
Thank you very much, Rose. That was certainly a very hot topic. Bonnie, go right ahead.
Oh, let me stop sharing. Or sorry, let me stop the recording. Sorry.